And before starting with the reading session, I would like to inform every student here that if anybody is interested in the membership of IEEE, then it is online available for students for $7 US, and for female candidates, it is complimentary. So the link will be shared with you. So if anybody is interested, they can apply for that. As for the today's reading session, we are pleased to have Anvesha Day with us. Anvesha is a 2026 computer science and engineering graduate from Techno India University. And during her undergraduate studies, she developed a strong interest in data science, machine learning, and NLP, with a broader focus on basically using AI to understand human behavior, decision making, and patterns in large scale data. She also worked on research projects spanning NLP, knowledge extraction, and AI driven analysis. And soon she will be joining IIT Kharagpur as a pre-doctoral research fellow, where her work will be focusing on mainly applying AI and machine learning to climate smart urban planning using remote sensing data. So, sorry for the glitch. Uh, so, Anvesha, you can now start the reading.
Okay. Am I audible?
Yes, you are.
Okay. Hello, everyone. Good afternoon. I will be screen sharing right now. Give me a moment, please. Is my screen visible?
Yes, it is visible.
Yes, your screen is visible.
Okay, okay. Okay, so I'll start with my presentation now. Okay. Hello, everyone. Today I will be presenting the paper Just for Trust, Mitigating Trust-Induced Inappropriate Reliance on AI Assistance. This was a very interesting paper I found, which had a really interesting take on the use of AI. And the authors of this paper were Tejas Srinivasan and Jesse Thompson. Now, I would like to give a brief of my perspective of the paper first before I start with the PPT. Since I have worked on use of AI and like the use of AI in academic misconduct, so like in a more negative sense, reading this paper personally was like it showed a different perspective on the usage of AI. And herein the very first question that we will be starting with is, what is trust, and to what extent should we trust AI? Okay, so beginning with this, the first we will see the agenda of the PPT. We can see that like we will start with the motivation, and as I said, the importance of trust and why this correlates with the paper itself. Then we will discuss the problem statement, the research gap, and the frameworks. After which we will go through the experiments the authors had done on this topic, and then the overall findings and the future work. Okay. So beginning with the subject itself, we start with the role of AI in our current era right now. Like as we can see that the AI is pretty much meshed with our daily life right now, and quite a lot of people use AI in like their day-to-day and daily tasks. It can range from very like trivial tasks in our daily lives to maybe some very important decisions. Now, most of the studies that have been done on this topic focus on the prediction accuracy of the AI models themselves. But to what extent does our trust and our reliance on AI itself affect it all? And should there be any way that AI should take that into consideration as well? Because as we all know, what is artificial intelligence? It's just it's just a lot of math with the uh, with the current technological progress, right? So, to what extent can we introduce the human emotions and the human trusting capability to those mathematical models? I feel like that was the main motivation behind this paper. And herein, the authors themselves also considered some very important domains for the test cases and the experiments, including healthcare and diagnosis, educations, legal decisions, and as well as financial recommendations. Okay. So, why is trust important? And what can under reliance or over reliance really mean in this scenario? So when we are trusting the AI answers or the AI advice too little, or we are very much skeptical, there might be some cases wherein our skepticism is actually not helping us in a way. Like maybe the AI answers were correct and its predictions were on the correct path, but we were too skeptical of it, so we didn't take that into consideration. There have been later on we will see that there have been some experiments in which maybe the user thought in a particular direction and AI maybe gave something in the same direction as well. The predictions might have overlapped, but the user was too much skeptical about the results itself and actually changed it to something else, which ended up not being the correct prediction. So, under reliance on AI can result in incorrect predictions. And then again, obviously, the over reliance on artificial intelligence is also never recommended because blindly trusting AI models can result to some incorrect recommendations from time to time. So, in either of these extreme cases, whether we are trusting AI too little or we are over trusting it, we might end up with some incorrect results, which, like, the implications of it might vary from use case to use case. But when we are using AI every day, for some people, every hour of the day, it, I think this is a very important aspect of AI research that needs to be brought to the light. Okay. So, as the authors uh, problem state. Hello. I'm sorry. Was there a glitch?
Maybe, but you are audible now. You can carry on.
Okay. Sorry.
You are audible now, Onisha. It's not an issue. You can carry on.
Okay. 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 So, as I was saying, as the authors proposed the problem statement itself, it was like their entire experiment was completely based on the like based on our capability of trusting AI. And it was not to maximize our trust, but to balance it properly, to kind of calibrate it properly. And their framework kind of follows this flow chart that we can see on the slide. That at the very first step, AI will give a recommendation, and the user themselves choose whether they want to rely on the advice or they don't want to. Now we can see here two particular metrics, that is trust too low and trust too high. We will get to see in the later slides that they had defined various parameters for it for to kind of uh, like uh, define this trust parameter, and they kind of feed it back into the loop. So like if the trust was too low, AI took that input, they had given a particular metric for it, and it would give like more information so that uh, the AI suggestion would sound more convincing, and it had more solid background and like solid reasoning behind it, so that the under reliance might be improved. And if trust was too high, then like the user is much prone to accept incorrect AI answers again, and it might result in over reliance. So in that case, the AI model, like it was trained to give some counter examples, like what might happen if the answer they gave is not correct, and what other situations are open, so that like the chances of taking an incorrect decision are low. Okay. So discussing the research gap here, there have been some research done in this topic, but most of them had very like static systems, like a static architecture. There weren't as many feedback loops into it, and they were mostly based on the confidence scores of the chat itself. Like there wasn't this concept of user trust. They focused on one strategy itself, and they focused on the confidence of the user, like analyzing the way the user is responding, rather than trying to uh, reflect if there is a sense of trust in those responses, and how much those responses are matching with the previous answers or the previous chats. So in that sense, this work kind of introduces a new adaptive and a new dynamic strategy. It measures the trust. It keeps a track of the chat, so it's a more personalized experience, a more personalized explanation, and most importantly, of course, it keeps a measure of the trust, right? So that it can feed back into the loop, and that metric can change the way it further interacts with the particular user. And then again, like when I was going through this paper and some of the other work like discussed here, one of the questions that stood out was, can AI adapt its behavior according to the user's preferences? On this particular statement, like to kind of answer the question that how much we can actually trust AI and how much its behavior can be adapted to with our interactions. And this was, I think, a very interesting study done in this aspect. Now, going over the methodological overview, as I said, we can see in this graphical representation that there is a feedback loop in the whole architecture. We start with the user, and via their chats and via their queries and problem, like the questions they're asking and their way of speaking, there is a trust estimation. Like the initial first few chats, there is a trust estimation done, that how much the user is relying on the chatbot, or like how much they're like agreeing with it or disagreeing with it, the way they are interacting with it basically. And based on that, there is a adaptive intervention there, which we will get to know the particular metrics of it. Now, on this, after this adaptive intervention done on like from the AI side, it notices the decision made by the human, right? Like what do we choose to do after that intervention is done, and that final answer, that final choice is it updates that trust metric, which we can see as the parameter one adjusted. It changes, it updates that metric, and it feeds back to the entire loop of the architecture, so that that metric can further affect that adaptive intervention. It can be further personalized for the particular person doing it. And overall, this was a very, as I said, it's a very trust adaptive framework, and it had a very personalized experience for every user, and it didn't give the same explanation to everyone. They had a they had manually set in the particular metric. If it was less than 5, as we can see, it categorized it as low trust. And then it would provide supporting explanations. And if the metric they found after the measuring of the user trust was above 8, then like that might be a case of high trust or over reliance. So in that case, the chatbot would give a counter explanation, that is an explanation of the other situations or the other uh, like the other stakes that might happen if the answer is incorrect. If the answer, if the trust metric fell in between 5 and 8, that was like determined as a moderate trust, and which is like a normal test case scenario. So in that case, no intervention was done and the chat proceeded normally. And from this flowchart, again, we can see this particular flow of the architecture, like from the decision task to the initial answer the user gave. It was saved, and the initial recommendation the AI gave again, the prediction plus the confidence. Now, this measure user trust thing is the novel introduction this paper made again, the trust metric. And based on the supporting explanation or the counter explanation, whatever the user decides finally, it updates the trust score, and it again feeds back into the next interaction. And again, the exact flow of it changed from person to person, because the way this flow chart would like go for a particular chat is again dependent on how the user reacts and interacts with the chatbot. So the authors in the paper discussed a very critical and very important scenario actually. As I explained, there was the low user trust and high user trust examples. And in our daily life, it can be some very trivial or very simple cases, right? Like whether we are asking some advice on maybe some homework, right? Maybe some maths homework or science homework that we are doing. It can be something very trivial. And but the cases that were discussed in the paper, those are of I would say some pretty significant importance. And one of the main cases they discussed was of a medical scenario in which the the doctor or the medical representative, they are asking the chatbot for a particular diagnosis given um, a set of symptoms, or maybe at times the documents, the x-rays, the charts, etc. And in this case, we will discuss the two cases that happened on the two extreme ends, right? Our case studies. In both the cases, the AI recommendation was pneumonia, right? But in one case, there was a chance of under reliance in which the user was skeptical. And from the previous chat, the chatbot determined that maybe there's a case of under reliance, and it would then provide a supporting explanation, like as we can see here, it would say like why it is determining that the diagnosis is pneumonia, based on which charts or which symptoms it is diagnosing that. At times it would even give mathematical metrics, right? Like the probability of this being the case, maybe a 75% probability, maybe a 90% probability. And based on what it is giving that metric, it would like explain the reasoning behind its answer. But again, if from the beginning the chatbot felt that um, the trust metric was very high and the user was perhaps over relying on the chatbot, then it would add some counter explanation, some counter examples with the answer. Like here, although pneumonia might be a possible case, tuberculosis or maybe some other diseases as well might happen because some of the systems are overlapping. So in this case, it would add in some extra scenarios with the original answer, so that the user are given, like the user is forced to kind of think for themselves as well, and there is a chance of lowering their trust metric here, and it basically depended on their trust levels to determine which kind of AI assistance the user would get. Now we will like go through the flow of the particular experiment in detail, like the way they designed it. They had both like normal users or lay users as well as medical professionals, because as I said, like most of the cases discussed in the paper were of a medical background or from uh, a medical point of view. And they had included medical professionals like doctors or nurses in it, as well as like normal users. And they used various data sets into the entire program, like ARC, reasoning questions, diagnosis, the charts, and some medical data as well, because it was mostly focused on that domain. Initial step was of obviously recruiting the participants, then of giving them a decision task, a particular question that they will be dealing with. In this case, determining the diagnosis of a particular case study, and like all through the AI chatbot. And then there's the initial human answer, like what they think the answer is. After which they then consult the particular AI model for its recommendation based on the same given set of information and questions. Uh, Now, based on that, and the from the conversation till now, it gives an answer, a recommendation, and from the like answer of the user, like whether they're agreeing with it or disagreeing with it, there is an adaptive intervention done, as in whether it's giving like whether it's giving um, like an underlying case study answer or an over reliance case study answer based on the trust metric. And based on that, they again note the final human decision, the final answer the user is giving. And overall, it gets a trust rating from 0 to 10. This trust rating again is fed back, which I said, and the normal trust rating as they defined was from the range of 5 to 8. Right. Okay, so they had different experimental conditions in it as well. There was the no intervention or baseline case study, in which there was only the prediction and just the user confidence metric given. There was another case in wherein the model always gave only supporting explanation answers. That is, considering this case that the user might be always under relying on the model, so it's always giving extra explanations, extra reasoning, extra like metrics behind why the answer might be correct from after every prediction. And the purpose was to test if constantly explaining might help with proper and unbiased decisions. The other test case was counter explanation always, in which case there is the particular answer the AI model is giving, but apart from that, it is also giving all possible cases that might be possible in every answer after every prediction. And the reason for this was again to measure uh, if constant counter explanations help. And then again was the novel model that they are mentioning, trust adaptive intervention, which is the explanation that is based on the current trust level, which is based on the entire chat history that's happened, and that is their proposed method of this paper. And they had defined 4 particular evaluation metrics of the final decision accuracy, under reliance, over reliance, and the total inappropriate reliance. And from the baseline, we can see the 4 particular conditions here. The baseline, always explain, always counter, trust adaptive, and then finally compare the results we get from the 4 types of test cases. Now, This was the first experiment which is under reliance with supporting explanations. That is, the AI model is always giving extra explanations, irrespective of the kind of answers it's getting. And it was found that in the cases wherein the supporting explanation was adaptive, was much more effective than always giving the same explanation. That is, 100 like giving extra explanations in 100% of the cases was less effective than when the particular model was built upon the particular chat history itself and it adapted to the particular user trust case. In this, right, so when for the users that were relying too less on AI and were a bit skeptical, from this particular experiment, they found these particular metrics, and overall, they saw that only when the user trust is low, it improved the decision quality. The next experiment was the other extreme case, that is always giving counter explanations. And it was again only found most effective when the user trust was already very high. So only when the user was already relying too much on the AI model was this particular experiment the most successful, that is giving counter explanation always. And in this case also they found particular metrics, that is how much giving explaining the overall situations helped with uh, explaining the overall situations helped with um sorry, where was I? One second. Right, so sorry, I'm really sorry. How it helped with the overall inappropriate reliance. And then again was the main two experiments that they did. That was a trust adaptive method. Now I'm saying two experiments because they again introduced another particular scenario, which was in experiment 4, and that is simply displaying AI is thinking and adding a time buffer before the particular result or the particular answer was shown. In this case, there wasn't much of an intervention from the trust metric itself. The answer itself wasn't much changed, but the time buffer itself was increased, and it was after a few seconds of delay that the answer was shown, and it was shown that AI is thinking. Now, this did not help if the user was already a bit skeptical, right? But in the cases that the user was blindly relying on AI, it did increase, like it did better the test results a bit, because in that case, the user got a time frame to actually think about the problem themselves, rather than just waiting for an instant answer from the AI chatbot. And the experiment 3 was the one that I have explained a bit earlier. That is when the trust metric was less than 5 or more than 8, depending upon the under reliance or over reliance situations, it would provide supporting or counter explanations. And in these two cases, like combining both experiment 3 and 4, they found the best results. That is, an adaptive method was found to be the most helpful for this particular experiments. And the last one was built upon the, like, experiment 5 was kind of built upon from the experiments 3 and 4, in which it was a more personalized chat, like a more personalized chat experience, wherein the chat history itself had a bit more relevance with it. And as we can see from the metrics itself, that this was found to be the most helpful, and the decision accuracy actually increased from like about 10% from 10 units, like from 58.4% to 67.8%. And the inappropriate reliance overall decreased quite a lot from 83.5% to 68.2%. Both under reliance and over reliance cases reduced significantly in this case. And for the experimental setup, as they described, they used Llama 3.18b assistant, arc reasoning benchmark, and for each condition or each setup, they used 30 participants in this. So from their overall study and the final results of their experiments, we can see that giving supporting explanations or like adding the reasoning behind the answers really helps when the user is a bit skeptical of the AI model. And on the other hand, counter explaining when the user is over relying on the model also helps to balance out the results. And based on both these two methods, the trust adaptive strategy, that is their final um mixed model, is the was found to be the best performing strategy, wherein the intervention was based on the user's trust level, and it consistently achieved the best overall performance. And wherever this particular framework was used, they saw that the decision quality was found to be better and more accurate than in cases wherein under reliance or over reliance interfered too much. Now, discussing the strengths and the limitations of the particular study, this actually addressed a really practical problem in human AI collaboration, wherein they considered a metric that is actually pretty much hard to define, trust itself. It's a pretty, humane metric, I would say, that they had tried to add into the mathematical model. And the framework was rather simple, but it was it was found to be pretty much effective, and it was also it's a very much extendable framework that can be added with multiple AI assistants. It can be scaled, and from all their findings, their proposed framework, it did perform the best. Like it was the best performing strategy out of all the particular test cases. But there were some significant limitations as well, mainly concerning with the um, size, like the dataset size. That is, it had very limited participants of only 30 people per scenario, and also the trust thresholds, which is the one of the main factors in this case, was like manually selected, and it was manually hard coded. So it might depend quite a lot from particular AI model to model, and it might need a lot of fine tuning depending on the model it is being attached, used with. And the entire experiment was, since the data set size, the experimentation limited was quite pretty small, so it was a very controlled environment, and there might be some multiple real world factors that weren't being able to considered in this particular finding. And also the trust itself, like one of the main metrics, it was self-reported. So there is again that particular factor that there might be a misrepresentation in the self-reported ratings. But if the dataset size is increased, and maybe more people are engaged with this particular experiment, with this particular study, perhaps more real world factors and inputs will be introduced into the strategy and the framework, and maybe a more robust framework can be given from this. But the strategy and the proposal in itself is pretty much novel and promising, and it did leave some pretty solid impacts. Now, discussing the future works of this particular study, one of the main things is actually integrating multiple more real world factors into it, integrating maybe this particular trust aware prompting into more advanced agents, LLM agents, validating the particular framework in the long term, because this was again a very controlled experiment, and uh, predicting, like this particular study was based on ratings instead of automatic predictions. So automating the whole process will also help into this, extending this trust adaptation into this multimodal framework. Now, finally, moving on towards the conclusions, we can see that, like, we finally reached a conclusion that yes, user trust does directly influence how we as humans are interacting with AI models and AI recommendations, and it is a very much important factor of how we are actually responding to the answers we get and the decisions we make. Number two, the adaptations, like the adaptive interventions introduced through this study, were found to be uh, effective in both the extreme cases that they had explained of under reliance and over reliance. And three, that trust aware AI, it's a pretty important step towards the human and AI collaboration, and it is something that I would say fall under the human computer integration kind of thing, and it is a domain that definitely needs more representation and much more focus, because it would definitely address some of the ethical concerns of AI as well, and maybe make it a much more reliable uh, a much more reliable source of information for us in general. And again, finally, the objective was not to maximize the trust, but to balance it properly as it should be in both real life and with AI models. So that I would like to conclude my presentation. Thank you everyone for listening to me till now.
Thank you, Anisha. That was really a wonderful presentation. Now, if anybody is having any doubts regarding the presentation, they can ask her now. Uh, and Anvisha, I also am having some doubts. I want to clear.
Question, Anu?
Yes, sir.
Yeah, I have one doubt to ask. Is this one a scalar value? This trust kind of scores,
Yes, it was a hard-coded value in this case.
like all of these values, the values that we get, all of their scalar values, right? Like
Yes,
some kind of point 5, 0.273,
yes.
like okay, okay, okay.
Anvisha, how are we getting these trust values? Like these are self created trust values.
Yes.
On what
Okay.
basis?
Okay, so this first of all, this range in itself was like it was manually input, like that less than 5 or greater than 8, and the particular metrics that we can see, it was self-reported, as we discussed in one of the limitations of the study. That sorry,
Yes,
it,
that self-reported trust value. How we are getting those values, even if it is self-reported, is that every user is mentioning the trust value of that particular result according to their effect. Is it
uh,
like that or something else?
It is a kind of hypothesis, I guess.
yes, like in this case, actually, mainly because the test case was so small, they relied a lot more on like manual intervention or like self-reported data in this case. It was only after this metric, like that less than 5 and greater than 8, after those metric were like introduced, kind of, or they were categorized, that the particular, I would say, the model comes into view, because based on that metric, it is then that the model is changing its answers. So everything before that first metric comes in, that whether the user is under relying or over relying, it is a bit like it is like self-reported in this case.
Mhm. So wouldn't it be better if we are using any formula apart
Yeah.
instead of
Look,
Mm,
these?
look,
yes,
look,
yes,
look.
yes.
If you have any kind of standard kind of work formula, then you can obviously go. But I guess they did not had such things in mind, or maybe they have not studied the background. So that's why they have done all sorts of experiment now to get the best results and to get a paper, they have those values like 5 and 8.
Yes, yes,
That is
yes.
my guess. Okay,
Like
after
they
seeing all
did
this.
mention that automating this process was mentioned in their future work, like automating the entire
Yeah, yeah.
data
Okay.
collection process.
No, not the data collection, but
And just
the
the
thing that the Bhanu just told. If we have some kind of predefined rules,
metric, right? So it
if
can be
yeah,
much more
rules, metrics, if
universal.
those are the things available, and placing those things in your total flow of work, that would have been better. But as they might not had that one, so they have gone in this way. Is this
Yes.
a journal paper or a conference paper?
This was so the journal, if I'm not wrong.
Okay, okay.
Anisha,
Yes, ma'am.
here you have talked about the trust calibration, right?
Yes, ma'am.
So, is it possible that cultural difference can affect this trust calibration?
It might be possible. I mean, in this case, again, they had a very limited experimentation case and they mostly focused on medical cases.
Okay.
Like, even the data set themselves here, it was mostly focused on medical decision making, the charts, and etc. So, herein, maybe in the factor of cultural differences might not be that relevant, but when we are talking about scaling this in the real world and actual implementations, then yes, um, it's very much relevant, I would say, and that is again maybe another metric that needs to be included in this, that needs to be thought about before assigning the particular trust's value.
Okay, so I just wanted to ask you another question. That have you gone through the paper and there is any statistical test in the paper?
Statistical test wise, they actually just they had shown these experiment values
Okay, okay.
mostly.
Oh, thank you. If anybody else has any question, you can ask her.
One more question, Anvesh.
Yes.
If we are implementing this in a real world scenario, hasn't it be a bit of manipulative also for some users? Like, suppose a user is getting a result which is right, and it is in under the trust score of below 5. Okay,
Hmm.
and the other result for the same thing is above 8 of trust score. The right one lies below 5, but the user would prefer the more trusted score metric now. So he might go for that one.
Wait. The you were saying that the correct answer falls in the category of less than 5 in the trust score,
Hmm.
like whatever the AI model is giving, right?
Hmm. He's getting the uh, AI predictions for that also, like जो AI लेस देन 5 के लिए उस रिजल्ट को बढ़ा के बताने का कोशिश कर रहा हो, that one he is getting the point, but he's also seeing that the another result is above 8 score, and he's getting convinced for that one. Then what happens? um,
Um, I mean, in general, if you're talking about one particular user in one particular chat, it's actually, I think, more the case that they will only see one version of the answer. Like if they're opening two different chats and interacting differently, they might come through different answers. But in one particular chat, uh, they will get one answer, right, based on the previous conversation. But I think, like, I can somewhat understand the question you're aiming at, like this segregation. It might result in like some manipulation in the answers, right? Like if two different people are like sitting with it. I think like when we are implementing this in the real world, as with like many features of AI, some caution must be taken. one feature that might be introduced is, I think, something that we actually see nowadays in most of the AI chat models, like ChatGPT and many other models. That is, we can actually choose which version, like which version is working better for us, or
Besides
like,
the responses we can choose, but the most of the data in those responses are same. And also one more thing, you said in a slide that it is compatible with different chatbots, so we can integrate it with ChatGPT or Gemini also, right?
yes, like they suggested that since the framework is comparatively simple, it can be extended to multiple models.
Just one thing I'm having doubts regarding is everything is in this project is manually intervenes.
Yes, yes, that is one of the limitations actually. This does need more work. It needs like much more experimentation. But I think the direction that they started in, it is worth looking into. Again, the question you were like, I think trying to ask before, like maybe I wasn't able to answer that properly. But like what I'm trying to say is, the users should be aware of the feature itself, right? Like they should be made aware of the feature that there is this trust metric thing introduced in the model. And if they do not want it, maybe there should be a feature to turn it off. Like there are multiple personalization methods in different models, right? So if
Yes.
this particular strategy is introduced in a model, the users do have a right to know that this is there. And if they don't think that, like if they think they don't want it, it's something they don't want in their answers, then they should have the chance to the choice to turn it off. Like I think that should help with a more unbiased experience with everyone.
Mhm. Okay. Thank you, Anvisha. Anyone else is having any questions? You can ask now. Anyone?
If anyone has any question, please ask her. So, Anisha, I have one question. Like it is to you actually. In this paper, all the measures are self-reported, right?
Yes, ma'am.
So, do you think it is like a reliable measure? Can we rely on this? If it is implemented in the real world, should
No.
we or can we rely on this since all of these are self-reported?
Based on this particular study itself, I would say no, because that's not a very statistically sound thing to do. But like the main reason why I chose this particular paper for this reading session today was the topic itself. And okay, I might be a bit biased in this, but my previous work regarding AI, it was more on detecting misconduct, like detecting the like it was more on the negative impact of AI and how we can detect the like the presence of AI in a negative sense. But I
Yes.
think this is a this is in a much more positive light. Like if more research is done on this, and if maybe more industry appropriate standards are brought into this framework, and it's actually built into the models, I think it would really help with the one, like the scenario I'm personally most concerned with is the over reliance, because that never really helps. Skepticism, if you have the knowledge about the particular domain, maybe it is okay if you're a bit skeptical about the particular thing. But if you don't have, like, if you are wrong, like, if your decision is wrong and you're relying on the AI answer, which unfortunately happens to be wrong as well, some kind of, I think, metric needs to be introduced in this. And I found this particular study a bit novel in that case, which is why I wanted to introduce it in today's session. But yes, statistically, this needs much more work.
Yes,
It,
I guess this one is a pretty like this one is like a research gap. We can show if we take this paper for some literature review, we can show the research gap through this.
yes, ma'am. Yes, ma'am. Yes.
Thank
If
you.
yes, ma'am. Thank you.
If anybody else has any question for Amnisha, please ask. Nobody has any question? Okay. Bhanu, you should carry on.
Okay, then we are concluding this reading session now. Thank you so much, Anvesha, for such a nice, helpful, and engaging session. I would also like to thank everyone for joining us today and actively participating in the discussion. Also, one of the link will be shared in the group for attendance, so everyone is requested to fill that Google sheet. Your attendance will be marked for that. And with that, we come to the end of the 8th week session. I also request all the students to actually positively engage with the speaker so that you can also clear your doubts more clearly and understand what things are there which you don't understand. Every paper comes with a novel perspective and new terms which you might not know, so it's a better chance to improve yourself and your doubts.
This is a very important thing what Bhanu said. I would request all the students, everyone here present, that all the students specifically, that please ask questions. Even if it is the stupidest question you can find. No
Yeah.
question is a stupid question. Just ask. Nobody is going to judge you here. Just ask what you need to know.
The whole goal of this reading session is that you can clear your doubts regarding the terms which you don't know. Means how are
Exactly.
you going to implement in your projects those things which you are needed, but you don't know about them. You are listening but not asking.
Listen what the speaker is saying. Ask them what you need to know. Connect them after the reading session so that if you have any doubt, they can make you clear the doubts. You can implement that in your research work or in your project, whatever you are going to do in future. Thank you everyone for joining. Please fill the feedback form. Thank you. You can leave.